Hello everyone, in this video let's discuss IDDFS algorithm in artificial intelligence and machine learning, that is Iterative Deepening Depth-First Search algorithm. So this is used to give the optimal solution than the DFS. First let's compare the DFS and IDDFS so that you will get the problem much easier. So here we have given the graph. The same graph I took here for the IDDFS also. First I will show DFS, then I will show IDDFS first. So we will be starting from the A node, that is root. In DFS, what we will be doing? We will be going as deep as possible. First we will be moving towards the left, then we will be moving towards right. So from A we will go to B, from B we will go to D, from D we will go to H. Now if you see, H is the leaf node, that is further there is no node from H. So 0 child node means it will be leaf node. So what I will be doing? I will be backtracking again. So D is not having any right node, so again I will backtrack to B. D and B are already written, so I not wrote them again. Now left is over, I will try to move towards the right side. So from B I can go to E. So after H I will be going to, here I will be writing. After H I will go to E. Because I don't need to write B again and again. Now I am here E. From E I can go to I. Because first left then right. There is no right child, so I won't write it again. So this is the leaf node, so I will backtrack again to E. E is already written. Again I will backtrack to B. B is already written. Again there is no right child, I will go back to A. Now if you consider A as the root node of the whole tree, left side is done. Let's move to the right side. So from A I will be going to C. From C first I must move to left, then I must move to right. So I will move to F. From F I can't go further because it is a leaf node, it is not having any child, so I will backtrack to C. C is already written. From C I can go to G. From C I can go to G. G is my goal state which I wanted to reach from the root node. So how many nodes I used to reach the goal state from the root node in the DFS? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I used 9 nodes to travel from the root node towards the final or the goal node. Now let's see in the IDDFS, which gives the optimal solution of the DFS algorithm. So how much nodes it takes to move from the initial or the root node A towards the goal or the final node G. So what we will be doing is we will be marking their level. This is level 0, this is level 1, and this is level 2, and this is level 3. So what we will be doing is we will be taking level by level. So here first let's consider level 0 only. So this will be the iteration number 1. Here we are having only one element, so I will be writing A itself. So all the elements which will be below will be not be considered in this scenario. Now I not got my favorable answer, that is I not reached my goal state. So I will be extending my level to level 1. Now I must consider level 0 and level 1 and find the path whether I can go from the initial to final node. So if you see, applying the DFS here also, first you will be writing the root node, that is A. From A you must go as deep as possible, that is you will move to B. From A you went to B. But after this, that is up to level only your cutoff is there, after that tree is not there. You must think like that. So you will backtrack again to A because B became the 0 child node, since this will not be considered. So A is already written, again you went to C. But you not went to your goal state G. So what you will be doing? You will be extending your level again. So from level 1 let's move to level 2. So level 0 will be considered, level 1 will be considered, and level 2 will be considered when you extend your level up to level number 2. Now again apply the DFS itself. So it is the iteration number 3. So here what you will be doing? I will be writing the iteration here because goal state is in the level 2 itself. You will get the answer here itself. First root node. A. From A, I will go as deep as possible using the left nodes. That is B, I will move. From B, I will go to D. Since my cutoff is up to level 2, all other nodes which are below level 2, that is from level 3, will not be considered. So D will become the zero child node, that is leaf node. So further I can't move. So what I will be doing, I will backtrack to B. So B is already written. From B, I will move to E because first I must move to the left node, then I must move to the right node. So from B, I will move to E. So B, I should not write twice, so I wrote once only, so I not wrote it again. Now, from E, where I can go, E is the zero child node since up to level 2 is my cutoff. So you will backtrack again to B, B is already written. You will backtrack again to A is already written. So if you consider the whole tree, A is my initial or the root value, which left hand side or the left subtree is already travelled. Let's search it in the right subtree. So from A you will go to C. From C you will move to F because first you must travel the left nodes. So F is the zero child node, so that you can be backtracking again to C. From C you will again go to G. So G is my final state. How many nodes we used to travel from the initial or the root node towards the final or the goal state? So 1, 2, 3, 4, 5, 6, 7. So 7 state we used, 7 state or 7 nodes we used to travel from the initial to the final node. Here in DFS we used 9 nodes. Here in the IDDFS we used 7 nodes. So this gives the optimal solution and also decreases the time complexity of the problem. Hope you understood the concept of the IDDFS algorithm in artificial intelligence and machine learning. If you have any doubt, please do comment below. If you liked the video, please subscribe and support us. Thank you.